Hey guys, welcome back to the second part of this course. In this section, I want to talk about the settings and other options for calibration of this model. In RR model, there are different types of optimization method. For example, you can use genetic algorithm or pattern search multi-star, uniform random sampling, Rosenberg multi-star, and pattern search methods for calibration of your model. And keep in your mind that there is no predefined or pre-selected best model for optimization, and you should choose all of these methods for your case study and try to find the best one for your data sets. So first of all, in this section, I want to select genetic algorithm, and also after selecting optimization method, you should select the primary and secondary objective. For primary objective, you can use Nash-Sutcliffe criterion, which is one of the most widely used criteria for evaluation of hydrologic models. And also you can use criteria or objectives such as sum of square errors, RMSE difference about bias, absolute value of bias, and other objective. And also, in order to improve your model performance, you can select a secondary objective. For example, you can use Nash-Sutcliffe, and also you use runoff difference in percent, flow duration curve, base flow method in order to optimize your model for simulation of, especially for low flow and high flow. And also you should try to test different primary objectives, and also try to use different primary and secondary objective combination. For example, you can select Nash-Sutcliffe and base flow curve, and models try to maximize the Nash-Sutcliffe criterion and also minimize the difference between observed and simulated flow duration curve. And also you can select calibration on monthly value if you have daily time scale, and the model calibrate your model at daily and monthly time scale. And also you can check the dynamic update in order to view the optimization results. Okay, at this time, let me to run the model with this combination. Click on calibrate, and to the calibration processes. Okay, let me. Okay, after the simulation, models try to maximize the Nash-Sutcliffe objective function. And also for visualizing the output, you can go to the graph type and select the scatter plot, and you can see the model in the calibration processes lead to Nash-Sutcliffe value of 0.5 or 59, and in the verification phase, it lead to Nash-Sutcliffe of 0.56, and this means an acceptable performance of this model. And also you can select other method, for example SCE, and calibrate the model. And some optimization method increase the time simulation of model, and some optimization method lead to a small time simulation. And also, using this optimization method is not very good for this case, and the genetic algorithms outperform compared to SCE model. And also you can use the pattern search multi-star and other optimization method, and finally compare the results and select the best one for your case study. Okay, let me select the genetic algorithm for this case. Let me click on calibrate on monthly value. However, my data sets are on monthly time scale. Okay, you can see the calibration improved a little more, and also you can plot different type of output. For example, scatter plot of monthly data set, observed and calculated runoffs, and also observe and calculate runoff versus verification. In other words, you can plot the output for calibration and verification results, and also difference after runoff. Flow duration curve, which is very important for environmental flow requirements, and using this option you can find is AWBM suitable for simulation of flow duration curve or not. And as you can see, for lower value the model performs a little bit low. Okay, and also in model calibration or method of calibration, there are other methods, especially for AWBM model. Go to the custom tab, and there is a special method for calibration of AWBM, which is called AWBM auto calibration. And also you can use this method instead of other methods for calibration of just for AWBM model. And also if you click on parameters, you can find the optimizer parameters of this model, for example, convergence criterion and maximum average capacity of using this method. And so let me click on calibrate. Okay, at a monthly time scale, this method leads to error, and I highly recommended you to use this method just for daily time scale. And also for manual tab, you can calibrate or test your model performance by changing the different parameters. For example, let me click dynamic update and update the graph. Okay, okay. By changing these values, you can find which of these parameters is very important or very important for AWBM output, or in other words, you can, by changing this value, you can find the more sensitive parameters of your model. For example, I think BFI is one of the most important values because it's change or control the base flow and low flow values, and by increasing the BFI index, the contribution of runoff increases, especially for low and high flow. And some other parameter, for example, A1, A2, C1, C2, C3 may be a little sensitive, low sensitive on the AWM output. And as you can see, by changing this value, the model performance is not so change over the time simulation. And also KABS, by using this value, the contribution of base flow increases significantly. Also, and this is the manual. However, I don't recommend you to use a manual method for calibration of this model, because if you use manual method, you should focus on just parameters, and the optimized combination never be gained. So I highly recommend you to use genetic algorithms for using this method, and also select primary and secondary objectives to increase the performance of your model simulation. And also in the VU time series, You can see the observed and simulated dataset, and also the calibration results. You can find the final, because the genetic algorithm using different combination and search to find the best one of model parameters, and finally the objective function and the variation of parameters in this part can be used for other purposes. Let me to find the best one, because these combinations are not good because they lead to the lower Nash-Radcliffe values. So the highest value is 0.47, and these are the optimized parameter. The range of A1 and A2 varies from 0 to 1, and the optimized value is 0.24. And if you want to use these values on or in your research paper, use these values for calibration or for optimized value of your model parameters. Okay, in the data statistics, you can see the values of mean, standard deviation, and skewness for runoff over calibration and verification phases. So I stop this video here, and in the third part, I will explain about sensitivity and simulation part or other remind parts. Have a good time. Bye.